Hello students, welcome back to my channel Computer Engineering Made Easy, and I am Anindita. I'm really glad to see that you all like my videos so much, and I will be addressing one of the comments left by IC today in this tutorial. IC has requested me to make a tutorial of how we can convert a sparse matrix given in the triplet format to its original format. So addressing her comment, in today's tutorial, I will show you how we can convert a matrix that is given in the triplet format to its original sparse matrix format. So stay tuned and watch till the end. So let's start by opening Xcode, and we will need a new editor for that, or rather a new project. So let's create a new project. It will be a command line tool, and let's call it trip to original. So next, and then create. Now, as we don't want to use any kind of command line arguments, I'll simply just skip this part, and I don't need anything inside. So what is our objective? Our objective will be to take a two-dimensional matrix as input in the form of a triplet, and then we will convert it to its actual original matrix. So for that, we need two arrays. So the first one will be the trip array, which we will be taking as input from the user, and the second one will be the original array that we'll be creating. So we will first declare the pointer to pointer to integers for that, and apart from this we need ing for that, for looping purpose. Now first we need to create the trip array, where we will be taking the user input and storing it. So for that we need to ask for the size of the original matrix. So I'll just consider that the triplet matrix has got size r cross 3, because the number of columns will always remain 3, but the number of rows usually varies. So r trip is going to hold the number of rows of the triplet matrix. So for that I'll just need to ask this as input for the user. So for that I'll write printf, enter the number of rows of the triplet matrix. Whatever the user provides as input, we will be storing it in the variable rtrip. So we got the number of rows. Now what we need to do is we need to create a two-dimensional array dynamically using this value of rtrip, and we will take the values as input from the user for that. Trip will be equal to int double star malloc rtrip into size of int star, and then what we need to do is we need to run a loop for I equal to 1 to, or I equal to 0 to rtrip, and then we will have to create single dimensional arrays of size 3 for each and every cell of the trip array that we have created till now. So for that I'll run a loop for I equal to 0, I less than r underscore trip, I plus plus. Now star of trip plus I will be equal to int star malloc size of int into 3. This is because the triplet matrix has got 3 columns. Now since we are using malloc, for the malloc we need the header file stdlib.h included, and now we have got our trip array already created. So when we have got the trip array already created, now we want to take user input. So printf, enter the triplet matrix. Done. So now in order to store the data in the triplet matrix, we again need to run a nested loop. So for I equals 0, I less than rtrip, I plus plus. This loop is for the rows of the triplet matrix, and then I need to write another loop for j equals to 0, j less than 3, j plus plus. This loop is for the columns. Now printf, enter the trip th element. And for that we need to write scanf star of trip plus I. This is going to identify the row number, and then again star of this entire thing plus j is going to give us with the column number. And if we give an ampersand before this, then that should work. But now the star and ampersand, they nullify one another, so we can skip both of them. And finally we can give a semicolon. So this is going to take the matrix as input. Now I have skipped this strip percentage, so here I need to write comma I comma j. So this is going to give us for the ijth element of the trip matrix. So once we are done with this, that means our triplet matrix is ready. So we can display that what exactly is the triplet matrix. So printf for I equal to 0, I less than r trip, I plus plus. For j equal to 0, j less than 3, j plus plus. Printf comma trip I jth element. Now after each element we will give a tab so that we get a nice spacing. We will simply give a printf \n over here so that the entries corresponding to the next line goes in their appropriate position. So this is going to display our triplet matrix. Now our objective is to generate the original matrix from the triplet matrix. Now when we get the triplet matrix, we know that the value present in the 0th position of the triplet matrix is going to give us the row number of the original matrix, and the value that is present in the 01th element in the triplet matrix is going to be the column number of the original matrix. So for that we use two more variables, say r and c. So these are going to be the row and column numbers. So firstly we will extract this row number. This is equal to going to be trip 0 0, and then the column number is going to be equal to trip 0 1. Now after this we will simply we will explore the triplet matrix, and the number of non-zero elements that we have is going to be available. Number of non-zero elements is going to be given as trip 0-2th position. It's going to be present in the 0-2th position. Let's declare an NZ first. So done. And now what we will do, we will explore the trip matrix and accordingly create the original matrix. So firstly what we need to do, using this R and C information, we need to create the original matrix. We need to allocate the space for the original matrix. So for that what we will do, we have got the original matrix marked as ORG. So ORG will be equal to int $malloc r into size of int star. Then for I equals to 0, I less than r, I plus plus, star of org plus I will be equal to int star malloc c into size of int. So there we go. Our original matrix structure has been created. Now first thing that we will do is we will store 0 throughout the matrix. So for I equal to 0, I less than r, I plus plus. For j equals 0, j less than c, j plus plus. Original I j equals 0. So this is going to store 0 throughout the matrix or throughout the original matrix. And now what we will do, we will specifically choose the positions where the non-zero elements are present, and then we shall store the value over there. So for that what we will do, we will simply go for I equals 1, I less than R trip. I plus plus. This is going to help us explore the individual rows of the triplet matrix. So if that's the case, now in the triplet matrix, we know that the 0th column holds the row number and the 1th column holds the column number of the non-zero element. So what we will do, we will simply choose the original matrices. Row number is going to be provided at ith row, 0th column of the trip matrix. So trip ith row, 0th column. Okay, so this is this trip I0. This is going to provide us with the row number of the non-zero element, and then we need the column number. Now where will the column number be present? It will be present in trip I1. This is going to provide us with the column number. So see, this is what is the row number and this is what is the column number of the non-zero element. And what is the non-zero element? The non-zero element will be trip I2. This is the non-zero element. So if we simply run this loop, then automatically it will explore all the corresponding rows which are associated with the non-zero elements, and they will be stored in the original matrix in the appropriate position. Now finally what we need to do is we need to display the original matrix. So for displaying the original matrix, we will simply use the similar code which is already written here, and we will modify it. So print the original matrix is I equal to 0 to R, J equal to 0 to C, and then we simply display original IJ. So this should be it. So now let's see if it's working. So I'll just give it a run. So here it is asking me for the number of rows of the triplet matrix. So I'll give it as an input like 8. So let's consider there are 8 rows of the original triplet matrix. 0, 0 is 5, 0, 1 is 5, 0, 2 is 7, 1, 0, 1, 3, 0, 3, 2, 2 is 2, and then 3, 0 is going to be 1, 2, 5, 2, 4, 7, 3, 1, 9, then 3, 3, 4, finally 4, 3 and 8. So once we do this, the original matrix that we get is something like this. So this is what the triplet matrix looks like. So I should have given a \n here. Let me just modify that and I'll execute it once again. I need to give the \n after the triplet matrix is and the original matrix is, so that will make it much more easier to follow. So here there will be a \n and here there will be another \n. So I'll just save my code and I'll run it again. So when I run it now, I am asked about the number of rows of the triplet matrix, which happens to be 8. And now as I enter the data, so 5, 5, 7, 0, 1, 3, 0, 3, 2, 1, 2, 5, 2, 4, 7, 3, 1, 9, 3, 3, 4, 4, 3, 8. So this is what the triplet matrix looks like. Okay, so we have 5, 5, 7. That means the original matrix is supposed to be a 5 cross 5 matrix, and the number 7 indicates the total number of non-zero elements in the original matrix. So these are the positions where the non-zero elements are present. So it's 0, 1 is 3, 0, 3 is 2, 1, 2 is 5, 2, 4 is 7, 3, 1 is 9, and 3, 3, 4, and 4, 3 is 8. So let's just tally whether these are the non-zero elements that we have in the original matrix. First, let's check the dimension. So if we can see that there are 5 rows over here, and there are 5 columns too. So this 5 and 5 gets validated. Now coming to the 7 non-zero elements, first one is at 0, 1 location. So in 0, 1 location, we have got 3. In the 0, 3th location, we have got 2. In the 1, 2th location, this is this one, we have got 5. In the 2, 4th location, we are supposed to have 7. So this is the 2, 4th location, so we have 7. Next, at 3, 1 position, we are supposed to have 9. So this is 9 here. Then at 3, 3, we are supposed to have 4. So 4 here. And finally at 4, 3, we are supposed to have 8. So that's what we have here. So this is how we can reconstruct an original matrix from its corresponding triplet matrix. So thank you.